We saw how to set up while loops, until loops, and for loops. There's a whole bunch of things you can try. I haven't given you examples of every single loop. Of course, that'd be hard to do. Next up, let's look at some statements that do exist in Java, the break statement and the continue statement, which work basically the same way as in Java or C or C++. Okay, so break is used to break out of a loop. The basic structure is you have a loop, and somewhere in there you can have an if statement, or you don't have to. You just have a break statement somewhere, and what happens is you exit the loop. So there's a difference between break and continue. Break gets you out of the loop and you don't execute. Once you hit break, you don't execute anything in the loop anymore. Okay, so I have a simple example of that. It's the very next file. If you have access to these files, it's good. But if not, you can take a look at this when I cat it. Here's a listing of this file. Same thing as in the notes that you just saw. I print out the number starting with from 1. If this number I is greater than 20, then I break out of the loop. So you could have done this loop with put this command up here in the while. In this case, you're basically setting up an infinite loop, and then based on some condition inside the loop, I exit from inside the loop. This is generally, it's probably not a good idea. It's just a you take this as just an illustration of how break works. So once you hit break, you exit the loop. So let's run this. That prints out basically the same thing as our while and until loops. So you can take a look at this, try it out. Okay. So besides break, there's also continue. So break, once again, break gets you out of the loop beyond the done or beyond the end of the loop, the next statement after the loop. Whereas continue, what it does is you execute some commands, and then if you hit continue, you go back and evaluate the condition again. And basically, ideally, you do the next iteration. But of course, if you miss out on, let's say if you're checking if I is less than 100, and you have an I++ after the continue, and you keep hitting the continue, of course you get stuck in an infinite loop. So there is that danger with continue, is that you may not get to update the thing that you're checking, and you might be stuck in an infinite loop. Okay, so you can try this out. If you can set up a loop with a break, you can probably also set up a loop with a continue. Remember to avoid the infinite loop problem. Okay, so arrays are somewhat different from the kinds of arrays we've used in Java. So you can do the same kinds of things too, but notice here we can set up an array with elements that are integers or strings. It turns out we can do this because these are all basically considered integers in bash scripts. You can treat the 4 as a number if you do certain operations. So remember, with basic scripts, all variables are always strings, but you can treat them as numbers under some situations. So that's why you can store numbers and strings. Actually, they're all strings in an array variable in a bash script. So you can, of course, arrays. Whenever you see an array, you don't have to look very far to see a loop. It's true in Java, true in bash scripts too. So here you have set up an array, and here's how you can go through all of the elements of an array. You set up an index variable. You say the index variable is less than however many indices you have. As in Java, you can start out from 0. That's usually the place where you start out in most bash scripts too. So try to stick to that convention. Of course, you can always skip the 0th one, but try to stick to arrays always starting at 0. Probably a good idea. And this, all it does is print out this array location. So to get at a particular location in the array, you have to use this syntax: $, open curly brace, the name of the array. Probably shouldn't have called it array, but whatever the name of the array is, and then square brackets, and use $I for the index variable. So remember to essentially dereference or find the value stored in this variable I. You have to use $I, and you have to also use $, and then curly braces for the actual array name itself. Then you just bump up the index. So this is something I think I have set up. Okay, now I can run this. And it just prints out all the elements of the array, 4, hello, 2, 12, and so on, up until this. Notice you don't have to do anything special for numbers or strings, they all just get printed. The -n over here is just to have them all print out on one line, just so that they don't fill up the screen with output. Okay, so you might want to try out basic arrays. This is something that will come in very handy. And next we'll move on to reading from stdin. So remember, stdin is just a keyboard. And so ordinarily when you use stdin, you're using input from the keyboard. But of course, if you redirect input, you can actually read from the output of, if you redirect input, you can read from a file and pretend that's coming from the keyboard. So although I'll be looking for now for situations where we read directly from the user typing at the keyboard, remember, just keep in mind that you could use redirected input. So how to use this statement? You just say read and then to a variable. And so whatever the user types in, the first string, and these are only strings, they're, you can treat them, you can actually have the user enter a number and treat it as a number, but remember, really, they're all just strings. You can also use the -a option and read a whole bunch of words into an array of strings. You can also say read -p and say something like enter your number, and then read that whatever the number the user types in, read that into the variable x. So often what I will do is, instead of using the read -p, I will just actually specifically put in an echo statement saying enter a number with a -n so that the user types it in on the same line as this text. So then I read that in and I say you entered this input file, whatever you read in. So let's take a look at this file I have set up. And here what I do is say it's basically the same thing that was in the notes, enter a number, and then I give it a space and a colon, read the input. So use the -n, that's very handy for user-friendly prompts. So if you were to run this, the nice thing about using the -n is that it types in the prompt and then it waits on the same line for me to enter some text. So I can say text, or I can type in a number. And it doesn't matter in this case. So, and then after that, what I do is I have a second set of, a second read statement, which will read in a set of values into an array. And I'll print out the entire array. So enter some words. And it doesn't matter how many you type in. Okay, and it prints out exactly the same words. It doesn't look any different. Okay, so if you are stuck and trying to figure out how to read in a bunch of values into one thing, here's one thing you can use. You can say read -a into this array, and then you have to use this way of accessing each of the elements of that array. And take a look at the loops too, the section on loops about how to access things in using a while loop. We just looked at that. Okay, another way that you can read stuff in is, take a look at this. You say while read, and as long as you're able to read things from a file, and this is the way you get input redirection inside a script. So this is all going to be inside a script. You can actually also do this on the command line, but there are some problems with this. It's much easier to do this inside a loop. So you say while read, do loop body, and here what you will do is read in one line at a time, and executes a loop body for each line that you read in from this file, assuming that this file name exists. I mean, assuming that a file with this file name does exist, then what you will do is you will read consecutive lines from the file specified by this file name, one line at a time, and executes the entire loop body, assuming that you've got a line to read. Okay, so let's take a quick look at that. See how that works. I believe is the script. Oops, this is a little bit different from what I just set up, but the same basic idea. So let's just go ahead and look at this script. This says while read, do this, and in this case what we're doing is we're piping the output of a cat. And you can do the same thing with greater than name of file. Or in this case, I could have used it greater than $1. Okay, so let's just try this out. And let's take a look at the description. So we are actually using this version of this read with loop. And so it works the same way as the loop we just looked at. Same basic idea. So here we're going to cat it, and you can use anything you want. And while you're able to read things, as that's the output of this command, you will do the loop body for each line of what you read from this command. So a simple command to use is the cat command, and this works just like input redirection with a greater than that we looked at earlier. So let's try a couple of things. Let's see, let's choose a simple file. I think scr1 is a good one. Okay, it has 3 lines. So if we were to execute lec 11-16 dot sh without an argument, then we will have some trouble. So let's make sure that we do supply a valid argument and run that, and notice that it prints out 1, 2, and 3. So why does it do that? Take a look at the code, and what you will see, oops, we don't have it, we don't have the exact code here. Let's take a look at the code over here. It's cat lec 11-16.sh, and what we've done is we initialize the value of this variable I to 1. We print out that variable, and then we bump up that variable. So all we're doing is for each line that we read in, we print out a number and then bump it up. So that's why we see the 1, 2, and 3 for a file that has 3 lines of input.